mathematics class. Today we discuss different kinds of problems on this section formula, and in the previous class also we have discussed. Today we will complete different types of problems that what we have on this section formula, right? And part of that, the first problem what we have is determine the ratio in which the line 3x plus y minus 9 equal to 0 divides the segment joining the points 1, 3 and 2, 7, right? See, I try to understand, my dear students, this particular problem, how it is given. Determine the ratio in which the line divides the segment joining the point. Let us take this first point as something like they have given a 1, 3, right? And b2, 7, like this. They have given b2, 7, like this. a 1, 3, b2, 7. Now, okay, they given that there is one line here like this. This is what the line L, like L is equal to, you have here 3x plus y minus 9 equal to 0, which divides the segment joining the points, right? This is dividing now, right? Okay, this line is intersecting the line segment joining of these 2 points A and B. Now we need to find the ratio. In what ratio this straight line is now dividing the line segment joining of A and B? That is what our aim now to find, like this. We don't know that ratio. Let us find. I told you that we can find anything m is to n or lambda is to 1. Anything is okay. Okay, let us take the ratio as something. If you take it as some lambda is to 1, like this, right? And where lambda equal to m by n, I told you that anything you can take, that's not a problem, right? Lambda is to 1 ratio, if we take that like. Now this particular point, okay, a, b, p, let us take this point P is dividing in the ratio lambda is to 1. Therefore, the point coordinates are nothing but, you know that, this is what the ratio and this is what the points x1, y1, right? And this is nothing but x2, y2. You have like this. Now, the coordinates of this point P is nothing but, okay, lambda x2, mx2. That means lambda here, m is to n means like lambda is to 1. You can take m is to n also, no problem. Lambda x2, lambda into 2 plus n is 1 into x1, x1 is 1 by lambda plus 1, comma, lambda y2, like this, lambda y2 is 7 plus, okay, right, and n into y1 is nothing but not 1, this is 3, like this, total thing divided by lambda plus 1, right? This is what the coordinates of the point P, like this. This is what the coordinates of the point P, right? That means what we have got, the P is nothing but, let us write properly, 2 lambda plus 1 by lambda plus 1, comma, 7 lambda plus 3 by lambda plus 1, like this we have got, right? Now we know that this point is a point which lies on the line segment joining of AB, which is a common point. It is a point of intersection for this AB and the line L, okay? Therefore, what we can do is nothing but this point P will satisfy this straight line, like this point P will satisfy this straight line. That means you substitute in that line, you will have that 3x plus y minus 9 equal to 0. That you put it here. Now if you get 3 into x, that is 2 lambda plus 1 by lambda plus 1 plus y. Y is nothing but 7 lambda plus 3 by lambda plus 1 minus 9 is equal to 0. Now, and you know how to simplify this problem, right? Now this is what we have got like this, and if we simplify this, you take the LCM as lambda plus 1 here, then we will get that on the numerator this is 6 lambda plus 3 plus 7 lambda plus 3 minus, because LCM is lambda plus 1, then we will multiply minus line lambda minus 9 is equal to 0. You can do the cross multiplication. then it will be totally 0. From that you will get 6 lambda plus 7 lambda, 6 plus 7, 13, minus 9. That means you will get 4 lambda, right? 3 plus 3 minus 9, that is 6 minus 9, that is minus 3 equal to 0. From that, lambda is equal to, we are getting it as 3 by 4. That means we know that the ratio lambda is nothing but m by n. We get the ratio as now 3 by 4. M is to n. M is to n is equal to, we got 3 is to 4. How nicely we have got here. See this different kind of problem, my dear students. We have found that point by internal division formula and you substituted in the given line equation. From that you have got lambda value. Lambda is nothing but m by n. From that you got m is to n ratio. It's a nice and a very, very important problem. Now the second problem, very interesting problem. Prove that the points, they given 4 vertices, like something you can take A, B, C, D, are vertices of a parallelogram. Is it a rectangle? Okay, we just take that, like this is something like this. The figure we take, let us prove whether it is a parallelogram or is it a rectangle or not. Everything we will try to get it like. Now this is A and this is B, this is C and D, like this. A, let us take, this is minus 2 comma minus 1, like this, and 1 comma 0, like this, and this is 4 comma 3, right, and this is 1 comma 2, like this. These are the 4 vertices, okay, of a quadrilateral. We need to prove whether it is a parallelogram or not. You know that in geometry, if it is a parallelogram, the diagonals bisect each other. The diagonals bisect each other means the midpoint of AC, right? The midpoint of AC and the midpoint of BD, they both should coincide. That means that the midpoints of AC and BD must be same. Now by section formula we know the midpoint formula. Therefore what we do is midpoint of, okay, midpoint of AC is nothing but this, we take it as x1 y1, this we take it as x2 y2, then it is nothing but x1 plus x2 by 2 comma y1 plus y2 by 2, like this. That means x1 is here minus 2 plus 4, minus 2 plus 4 by 2 comma minus 1 plus 3 by 2, like this. Now this become 2 by 2 is 1 and this is 2 by 2 is 1. Therefore you have got midpoint of AC as 1 comma 1, nicely we have got, right? That means you know that if it is a parallelogram, since we have completed section formula, we got midpoint formula. Now we are eligible to apply the midpoint formula instead of distance formula. We are using section formula now. Okay, midpoint of AC we have got nicely. Next we will get midpoint of BD, like this. You see here midpoint of BD, like this. This is also equal to, you see my dear students, B and D, this x1 y1, this x2 y2 we can take, right, and this is nothing but 1 plus 1 by 2, right, okay, x1 plus x2 by 2, this is now 1 plus 1 by 2 comma and 0 x2, okay, this is what, y1 plus y2 by 2, 0 plus 2 by 2, this is now 0 plus 2 by 2, you have got like this, right, this is what the coordinates you have got now. This is now 2 by 2 and this is also 2 by 2. This is now 1 comma 1. Okay, fine, very good. Now the midpoint of AC is equal to midpoint of D, okay, BD. Like you see, midpoint of AC is equal to midpoint of BD. Right? This is what midpoint of BD. That means the diagonals are bisecting each other. The diagonals are bisecting each other means this is a parallelogram, no doubt in it. It is a parallelogram. Therefore, you can write that as ABCD is a parallelogram, like this. ABCD is a parallelogram. Okay, we have got nicely that ABCD is a parallelogram. Now we have to check whether it is a rectangle. Rectangle means if a parallelogram becomes a rectangle if the lengths of the diagonals are equal. If the lengths of the diagonals are equal, that means if you prove that AC equal to BD, then it will become a rectangle. Otherwise, it is not a rectangle. Then it will become only a parallelogram. Okay, now we will check it. Now, let us find the length of AC, the diagonal lengths. Length of AC is equal to, we know by distance formula, you take x1, y1, x2, y2, square root of x2 minus x1 whole square. This is now 4 minus of minus 2 whole square plus 3 minus of minus 1 whole square, like this, right? And this is nothing but you have got 4 minus of minus 2, 6 square you have. This is 4 square you are having, like this. This is now, right, you have 36 plus 16 you have, like this, right? Okay, 4 that is now 36 plus 16, right? That is nothing but you can write it as 2 root 13, like you can write that as 2 root 13. If you simplify that, you get it as 2 root 13. Next, in the same way, length of well, let us find BD, like this. This is nothing but square root of BD is nothing but this is x1 y1 and x2 y2. Therefore, x2 minus x1 whole square, 1 minus 1 whole square plus 2 minus 0 whole square, like this. That means square root of 0 square plus 2 square, that is nothing but 2, right? Now, the length of AC is not equal to BD. Therefore, you have got the AC is not equal to BD. Therefore, here the diagonal lengths are not equal. In a rectangle, the diagonal lengths are equal. Therefore, it is not a rectangle, it is only a parallelogram. In this way, we will be doing this particular problem, dear students. Now, one more interesting problem. We have the 3 vertices of a parallelogram. They given 3 vertices of a parallelogram taken in order. These are the 3 vertices they have given, like this. Find the coordinates of the 4th vertex. We need to find the coordinates of the 4th vertex. A very good and interesting problem. Let us observe and do it this now, like how we are going to do. You please observe, dear students. The 3 vertices of a parallelogram they have given like this, right? Let us take a parallelogram like this. Let us take A, B, C and D, like this. A is given as minus 1 comma 0, right? And B is given as 3 comma 1 and C is given as 2 comma 2. And we don't know D, let us write this as some x comma y, right? And we know that, my dear students, if it is a parallelogram means we discussed the diagonals will bisect each other, like the diagonals bisect each other, like this. That means the midpoint of AC should be equal to midpoint of BD, right? That means what we are going to have is midpoint of AC is equal to midpoint of BD, like this. Midpoint of BD, like this, right? That's nice. Therefore, let us find that only midpoint of AC is equal to here A and C. We know the formula x1 plus x2 by 2. Midpoint formula minus 1 plus 2 by 2. Midpoint of AC. This is equal to what we are going to have is x1 minus 1 plus 2 by 2 comma, okay, and y1 plus y2 by 2. That is 0 plus 2 by 2. This is what midpoint of AC. And let us try to find whether they are equal or not, like midpoint of BD. BD is nothing but 3 plus x by 2. That is 3 plus x by 2. Okay, from that we will get the coordinates of x and y, like this. And y 1 plus y by 2, like this. Right? Now, we get minus 1 plus 2 by 2 is 1 by 2, comma 1 is equal to x plus 3 by 2, comma y plus 1 by 2, like this. Now you equate their corresponding coordinates, x coordinate. Now x plus 3 by 2 is equal to 1 by 2 and y plus 1 by 2 is equal to 1. Now this 2 will cancel, x is equal to 1 minus 3, x is equal to minus 2 you have got, y equal to, this is now actually y plus 1 is equal to 2 by doing the cross multiplication like this. And it is very simple, you know that 2 minus 1, that is 1. Therefore, you have got the vertices, the vertex D, the coordinates of D, that is nothing but minus 2 comma 1. Okay. Now the 4th vertex, you got it as minus 2 comma 1. In this way you will do this beautiful problem. It is very easy, and how you applied the section formula here, that is what the midpoint formula you applied. By that you are getting this particular problem, right? Now the 4th problem, very much interesting problem. This if the coordinates of the midpoints of the sides of the triangle, they given here the midpoints of the sides of the triangle, right? Remember carefully, these are not the vertices, they given this as midpoints of the sides of the vertices. These are the midpoints of the sides of the vertices, they have given like this, right? Find the coordinates of its vertices. So that means, you see, dear students, they given, my dear students, here A, this is B, this is C, like this. And they given, let us take, this is what, suppose D is the midpoint of BC, and that is given it as 1 comma 2, like this. And E is midpoint of CA, like this, right? Okay, fine. Let us take E as 0 comma minus 1, like this, fine, right? And D, E, F, like this. F is the midpoint of AB, and that is given it as 2 comma minus 1, like this, 2 comma minus 1, right? Fine. Now we have given the information like this. Now let us take we need to find now the vertices. D, E, F are the midpoints they have given. Now let us find the vertices x1, y1. Let us take the vertex A as x1, y1, B as x2, y2, like this. B as x2, y2, and C as x3, y3, like this. Right? C, we take it as x3, y3. Now once we have got the three vertices, you know that now, my dear students, the D, here F is midpoint of AB, therefore, right, what we can write is the midpoint of, see here, midpoint of AB is equal to F, right? This is what F. F is nothing but 2 comma minus 1. They given like this. That means we can write nicely, this is midpoint of AB means x1 plus x2 by 2, comma y1 plus y2 by 2, because this is x1 y1, this is x2 y2, that is equal to 2 comma minus 1, like this. Let us equate their corresponding coordinates, right? That means now here you will get x1 plus x2 by 2 is equal to 2, and another one you have got y1 plus y2 by 2, y1 plus y2 by 2 is equal to minus 1. From this you will get a nice equation, x1 plus x2 equal to 4, and y1 plus y2 is equal to minus 2, right? This set of things you put it in the box like this, right? And you can call, okay, write as some equation or something like this. Now let us take that the midpoint of BC as D here, the midpoint of BC as D. From that you see, my dear students, so therefore what you will get, x2 plus x3 by 2, midpoint of BC as, okay, this is x2 plus x3 by 2, comma y2 plus y3 by 2, this is what midpoint of BC, that is nothing but D. D is nothing but now 1 comma 2, right? Now you equate, okay, let us equate their corresponding coordinates. From that what you will get, x2 plus x3 by 2 is equal to 1, and another one y2 plus y3 by 2 is equal to 2, like this. Now from this x2 plus x3 is equal to 2, and y2 plus y3 equal to 4. You keep it in the box, you call it as some equation number 2, like this, right? You call it as some equation number 2. Now we have got two sets of equations. Now in the same way, midpoint of AC is E, that's what we have got. This is x1 y1 and C as x3 y3. Midpoint of AC is nothing but x3 plus x1 by 2 and y3 plus y1 by 2, that equal to 0 comma minus 1. Now let us equate their corresponding coordinates, x coordinate and y coordinates, like from that x3 plus x1 by 2 equal to 0, and y3 plus y1 by 2 equal to minus 1. Now from that x1 plus x3 equal to 0, and y1 plus y3 equal to minus 2 by doing the cross multiplication. You call it as some, okay, set 3, okay, equations number set 3 you take like this, right? Fine. Now by adding the equations 1, 2 and 3, the x coordinates parts, x1 plus x2 x2 plus x3, this is one set, x3 plus x1, 4 plus 2 plus 0. This we are going to get, there are two x1s, this is one x1 and this is another x1. This is two x1s, two x2s you are with, this is one x2, another x2 is this, and x3, two x3s, this is equal to 6 you are having. From that we have got x1 plus x2 plus x3 is equal to 6 by 2. 6 by 2 is nothing but 3. We have got a nice equation. Let us call this as some equation number 4, like this, right? Now in the same way, let us add all the y coordinates, the set of y coordinates by adding 1, 2, 3. We get y1 plus y2, these things like minus 2 plus 4 minus 2. These two y1s are there like this. This is 1 y1 and this is 1 y1. Now 2 times of y1 plus y2 plus y3 equal to 0. Now y1 plus y2 plus y3 equal to 0 by 2, that equal to 0. Let us call this as some another set of equation, like we have got now very nicely, dear students. We have got the this is fifth equation. Now from that let us try to solve our equations very easily, like now we have got these are the set of equations we obtained. Now we need to get the vertex A, B, C. A is x1, y1, right? And this is x1 plus x2 plus x3 equal to 3 and y1 plus y2 plus y3 equal to 0. As we told you that, now you see, my dear students, I will substitute here, right, x1 plus x2, okay? If I substitute in this x1 plus x2, that is now 4 plus x3 is equal to 3. And also y1 plus y2 I will substitute here. That means minus 2 plus y3 equal to 0. From that I have got nicely x3. x3 as 3 minus 4. And y3 as 0 plus 2, like this. That means x3 you have got it as minus 1 and y3 you have got it as 2. Now therefore now x3 comma y3 is nothing but minus 1 comma 2, like this. Now nicely we have got the vertex C. C as minus 1 comma 2 you have got. In the same fashion we will try to get the other things like this, right? Now you see, let us use this one, right? Now let us use this one, okay? And get x1, y1, vertex A. You know that x1 plus x2 plus x3 equal to 3. And you know that x2 plus x3 equal to 2. This you see, my dear student. You know x1 plus x2 plus x3 equal to 3. And y1 plus y2 plus y3 equal to 0. Let us substitute now x1 plus x3 equal to 2 here. x1 plus x3, okay? So yeah, sorry, this is x2 plus x3. That means x1 plus 2 equal to 3 and y2 plus y3 equal to 4, right? That equal to 0. Now x1 is equal to 3 minus 2 and y1 is equal to 0 minus 4. x1 equal to minus 1 and y1 equal to minus 4. Nicely we have got now the vertex A. That is what x1, y1, that is nothing but minus 1 comma minus 4. How nicely we have got that you observe, right? Fine. Here, okay, sorry, this is x1 is equal to 3 minus 2, that is 1, and y1 is equal to minus 4. Therefore, x1 comma y1, the vertices of A are 1 comma minus 4. Right? Nice. In the same way, let us try to get, now we got A, the coordinates of A, the coordinates of C we got. Now let us get the coordinates of B. In the same way here, you see, my dear students, you know that x1 plus x2 plus x3 equal to 3. And y1 plus y2 plus y3 equal to 0, like this. Now to get the coordinates of B, that is nothing but x2, y2. We know x1 plus x3 equal to 0. We know that x1 plus x3 equal to 0. And we know that y1 plus y3 equal to minus 2. Let us put it here now. That means you will get x2 plus 0 is equal to 3. And y2 minus 2 is equal to 0. That means x2 equal to 3 and y2 equal to 2. Therefore, the vertex B and the coordinates, its coordinates x2 comma y2 is nothing but 3 comma 2, like this. Right? This is nothing but 3 comma 2. Like that, my dear students, now you have got the vertex A you have got. This is what we need to find. A and B we have got. C also you got. This is the way how you will do this beautiful problem. Right, my dear students? Like this, we'll be doing this particular problem. Now we have another interesting problem. They have given, see, the coordinates of one end point of a diameter of a circle one end point they given 4 comma minus 1, and center is given, and we need to find the other end of the diameter, like find the other end of the diameter. You see, this is a very simple, if you get the diagram of it, this is what you have. One end of the diameter, one end of the diameter is now 4 comma minus 1, and the center, this is, let us write O, we will write this as, they have given it as 1 comma minus 3, and this is B, we don't know, X comma Y, let us take. And you know that, my dear students, this is the center, means this become OA is the radius, AO or OA is the radius, OB is also the radius. This is what the radius, that means this is the midpoint. That means now let us apply the midpoint formula and we will try to get it. Now, you know, the midpoint of AB is nothing but O. From that we will be getting it. That means 4 plus X by 2 comma minus 1 plus Y by 2 is equal to, you have got 1 comma minus 3, like this. From that we can equate them nicely and we will get X and Y values. 4 plus X by 2 is equal to 1, and minus 1 plus Y by 2 is equal to minus 3, right? Now from this 4 plus X is equal to 2, and minus 1 plus Y equal to minus 6, and X is equal to here minus 2, you will get 2 minus 4, minus 2, and Y is equal to minus 6 plus 1, that is minus 5. Therefore you have got the other end is nothing but minus 2 comma minus 5, or the coordinates of the other end, minus 2 comma minus 5, we have got very nicely. This way these problems are going to be. Okay, thank you dear students, thank you for watching. Please subscribe, share it and like it, and totally write in your class works these problems.